Hi class, Professor Harrison here. In this video I'm going to take you through a bond problem. In this particular bond problem, the bond is issued at a discount. So first we're going to start off with a very careful reading of the problem to make sure we've got all the pieces. Borgnine Incorporated, an entertainment company, is going to issue bonds to fund their next project. The amount of the bond offering is going to be $1 million, and they will pay semi-annual interest at a rate of 6%. And the principal at the end of the bond's life cycle when they mature in 7 years. The market interest rate for similarly rated bonds of similar length is 10%. First, we're going to calculate the present value of the bond. Second, we're going to calculate the cash that is paid upon the bond in the first year. And third, we're going to calculate the interest that is paid upon the bond in the first year, the interest expense. So there are two parts to the puzzle when we need to figure out the present value of bonds, or how much cash Borgnine is going to receive when they issue these particular bonds. We first need to figure out what is the present value of that annuity stream of all those payments. The annuity amount is, we're going to take the principal value of the bond, principal, we're going to multiply it by the rate. This is the coupon rate, the one that is built into the contract of the bond, and that's 6%. And we'll multiply that by the time that this is going to happen, which is every 6 months or 1/2 of 1 year. Because the 6 months, or 6% rather, is done on an annual percentage, we're breaking that down into semi-annual amounts. That's going to be our payment. Our payment is going to be $30,000. We're going to pay that amount every 6 months. As you can see by my little graph here, there is no final payment or principal payment after the last annuity payment. We take now the market interest rate. The market interest rate is 10%, but that is an annual rate. We divide it by 2 to get a semi-annual interest rate, 5%. The number of periods that this bond is going to pay is 7 years, but since it's paying semi-annually, or twice per year, we multiply that by 2, and we're going to pay in 14 periods. We then take our amount that we're going to pay, our payment, $30,000, and we multiply that by a present value annuity factor. We go to our tables and we look up our present value annuity factor, which is the present value of an ordinary annuity. That's the table we go to. We run our finger over to 5% and then down to 14 periods. And what we find is that the present value annuity factor is 9.89864. When we multiply our $30,000 by our present value annuity factor, we get that that has a present value of $296,892. Well, that's the first half that we need to do. The second half is we need to figure out what is the present value of that principal payment. That principal payment is in the future, and we know that because it's in the bond contract, $1 million. There are no payments along the way, so all we need to do is figure out what is the present value of this. The interest is also based off the market rate. Market rate for similar bonds is 10%, but that's an annual rate. We're going to pay semi-annually or compound semi-annually, so we divide that by 2. The interest rate that we're interested in is 5%. The number of periods, there are 7 years for this particular bond, but since we are compounding on a semi-annual basis, twice per year, we multiply that by 2. We find that there are 14 compounding periods. To find the present value of this single amount, we go to our table. The present value of a single amount, we run our finger over to 5% and then down to 14 periods. And we find that our $1 million is multiplied by a present value interest factor of 0.50507. When we multiply our $1 million by that present value annuity factor, we find that the present value is $505,070. We then add what we got for the present value of our interest payments, $296,892. $892 to the present value of our principal amount, $505,070. And we find that the total value or amount of cash that is going to be received when this bond is issued is $801,962. It's at a discount. We take that present value as the bond is the beginning value for our next chart, $801,962. The cash that's going to go out the door is based upon the bond contract. That's going to be $30,000 in this example. The interest expense takes the market interest rate, 10%, adjusted for the time period, divided by 2, 5%, times the beginning value of our bond. We find that value to be $40,098. That's going to be the interest expense for our first 6 months. You notice that there's a significant difference between the cash that's going out the door and the interest expense. We take that difference, which happens to be $10,098, and we add it to the beginning value of the bond. That makes our ending value of the bond $812,060. And what you'll start to notice is we're driving the value of the bond towards what we're going to have to pay off, $1 million. We copy down that ending value, $812,060. We know that our semi-annual coupon, cash out the door, is going to be $30,000 for that semi-annual period, $60,000 for the year. We take this beginning value, we multiply it by our market interest rate, adjusted for time, 5%, and we get $40,603. That's going to be our interest. We take the difference between the cash out the door and the interest expense, that $10,603. We add it to our beginning value, the ending value of our bond, $822,663. The cash that went out the door, $60,000. Our interest expense for that first 6 months is going to be $80,701. So to summarize, the present value of the bond in this example, $801,962. Cash out the door, $60,000. Interest expense, $80,701. I hope you found this video helpful. Thanks for watching, and I'll see you in class.